Hello everyone. Today in this video we'll be seeing the solution of partial differential equations, some basic definitions and some of the types and how to find the solution of those types. So I'll give some basic definitions. First one, a solution or an integral. Solution is otherwise called as integral of a PDE is nothing but it is a relation between independent and dependent variables. So a relation between independent and dependent variable which satisfies the given PDE is called a solution. And next one, there are two types of solutions for a PDE. First one, a solution containing arbitrary constants, and next one, the solution containing arbitrary functions. So next, there are many types of solutions. First one, complete integral or complete solution. So this type of solution contains arbitrary constants, and the number of arbitrary constants will be equal to the number of independent variables. If this is true, then that type of solution is said to be a complete solution or complete integral. And next one, particular integral. So particular integral, it is obtained from complete integral by giving some particular values to the arbitrary constants. So if a and b are arbitrary constant, and if I am assigning some constant values to those a and b, then I'll be getting the particular solution. Next one, singular integral. Singular integral, it is also obtained from complete integral. However, we have to eliminate the arbitrary constants. So the solution obtained from complete integral after eliminating the arbitrary constants is called as singular integral. And the last one and very important one is general integral. So any solution which contains maximum number of arbitrary functions as possible is called as general integral. So we have to be careful. Always complete integral is associated with arbitrary constants, and general integral, it is associated with arbitrary functions. So next one, method of finding singular and general integral from complete integrals. So let us consider this phi function dependent on x, y, z and arbitrary constants a, b as the solution of the given PDE f of x, y, z pq is equal to 0. From this complete integral, we are going to obtain the singular integral and general integral. So as we have seen in definition, obtaining singular integral from complete integral is nothing but we are going to eliminate these arbitrary constants a and b. Now how to eliminate this arbitrary constants? We are going to differentiate this equation phi with respect to a and then equating that to 0. And similarly we are going to differentiate this equation phi with respect to b and we have to equate that to 0. So we will be getting three equation, the complete integral equation, and dou phi by dou a is equal to 0 and dou phi by dou b equal to 0. So using these three equations, we can eliminate the constants a and b and then we will be obtaining the singular integral. And next one, obtaining complete integral is nothing but, observe that there are two arbitrary constants given in complete integral. So what we are going to do is we are going to name this another constant as some other function of the previous constant a. So observe that this equation 4 there are only one arbitrary constant. So in next step I am going to differentiate this one with respect to a. So I'll be getting dou phi by dou a, and observe that this function phi is dependent on g and g is dependent on a. So if I am differentiating phi with respect to a, first I have to write dou phi by dou g and then g dash of a. And note that just g is dependent only on a. So here I'll be writing ordinary derivative. Now eliminating the constant from solving these two equations, we can get the general integral. Eliminating a from equations 4 and 5, will be getting the general integral of the PDE. So there are four standard types of first order PDE. First order PDE in the sense the equation will contain the terms p and q only. So first type is function of p and q. There will be p and q alone will be there. the equation containing P and Q 1D. And type 2 is of the form Z equal to Px plus Qy plus f of Pq. So this form is known as Clairaut's form, and this type of problem is very important. Type 3 is function of Z P Q is equal to 0. So that is equation not containing x and y explicitly. And fourth type is separable equations. We will be able to separate x and p at one side and y and q in another side. So let us take type 1 of problem to find the complete integral. So given that f of p comma q is equal to 0. So for this type of problem, we are going to assume a trial solution. Trial solution in the sense, we are going to take z is equal to ax plus by plus c. So we are taking this one as a trial solution because observe that if I differentiate dou z by dou x, I will be getting a, and similarly dou z by dou y will be B. So P can be written as A and Q can be written as B. So instead of PQ in the function f of PQ, I can substitute A and B. So I'll be getting an algebraic equation. Solving that algebraic equation will be easy. So I'm going to take this z equal to ax plus by plus c as the trial solution of type 1 problems. So then the same thing which I have told earlier, P is equal to dou z by dou x equal to A and Q is equal to dou z by dou y is equal to B. We'll be getting f of AB when substituted P for A for P and B for Q. Now what I'm going to do is, I'm going to write B as some function of A. That is, since f of AB is equal to 0, from this equation, I can write B in terms of A, that is beta of A. Now substituting beta of A here, we can observe that A is an arbitrary constant, C is an arbitrary constant. So there are two arbitrary constants and two independent variables. So since the number of arbitrary constant is equal to the number of independent variable, this equation 2 is called as the complete integral for type 1 problems. Next, I am going to find singular integral. So to obtain singular integral, I am going to eliminate the arbitrary constants a and c from complete integral. So complete integral, that will be my first equation, and then differentiating this one with respect to a, that is dou z by dou a, that will be my second equation, and dou z by dou c will be third equation. And observe one thing, the second one I can write it as, so a plus beta dash of a into y, this will be equal to 0. This will be my second equation. But when I come to third equation, so dou z by dou c is nothing but 1 because the first term is independent of c, second term is independent of c. And here if I differentiate c with respect to c, I'll get 1. And equating 1 to 0, which is absurd. There is no meaning for this one. It is meaningless. So there is no singular integral for this type of problem. So for the type where f of p comma q is equal to 0, there is no singular integral. This is one of the important point to be noted. Okay. And next one, general integral. So from the complete integral, I'm going to substitute the second arbitrary constant cs delta of a. So I'll be getting z equal to ax plus beta of ay plus delta of a. This will be by next equation. And differentiating this equation with respect to x, with respect to a, I'll be getting x plus beta dash of a into y plus delta dash of a is equal to 0. Now eliminating a from these two equations, I'll be getting the general solution. Okay. Let us see some problems from this type. So first question, I'm going to take PQ is equal to 1. So complete integral, I'm going to assume the trivial solution as z equal to ax plus by plus c. So as I have told you earlier, P can be written as A and Q will be B. So instead of substituting PQ, For PQ, I am going to substitute A and B in the given equation. So since PQ is equal to 1, it is given. This can be written as AB equal to 1. So B can be written as in terms of A. This 1 by A is nothing but the beta of A term given in the method. So our solution will be Z equal to AX plus 1 by AY plus C. This is our complete integral. So this is equation 2 is our complete integral. So next one we are going to find the singular integral. Finding singular integral is nothing but keeping the equation z equal to ax plus 1 by ay plus c as it is, and then differentiating this equation with respect to a. So I'll be getting x, and if you are differentiating with respect to a, y will be constant. So 1 by a, derivative of 1 by a will be minus 1 by a square plus this will be 0 is equal to 0. So it is x minus 1 by a square y will be equal to 0. And third one, differentiating this with respect to c, we will be getting 1 is equal to 0, which is absurd. So there is no singular integral. But anyhow, we have to write the steps for each and every problems. Last one, finding the general integral. So we are going to substitute z c is equal to delta of a. So the complete integral will be z equal to ax plus 1 by ay plus delta of a. And then differentiating this one with respect to a, we will be getting x plus minus 1 by a square into y plus delta dash of a is equal to 0. That is x minus 1 by a square y plus delta dash of a is equal to 0. Now take this as equation number 4. Eliminating a from 3 and 4, we will be getting our general integral. Next question, we are going to solve p square plus q square is equal to 1. To find the complete integral, we are going to take the trial solution z equal to ax plus by plus c. So p can be written as a and q can be written as b. Substituting both the things in given equation, a square plus b square will be 1. So b square can be written as 1 minus a square. B can be written as square root of 1 minus a square. So our complete solution will be z equal to ax plus square root of 1 minus a squared y plus c. So this is the complete integral or complete solution. Okay. Next one, we are going to find the singular integral. Similar to previous one, there will be no singular integral here, but anyhow we have to write the steps. First one, we are taking the equation as it is, root of 1 minus a square into y plus c. This is equation. And next one, we are going to differentiate this one with respect to a. So it is x plus, we can consider this term as 1 minus a square the whole power 1 by 2. So it will be 1 by 2, 1 minus a square, 1 by 2 minus 1. And if I differentiate this one, so it is 0 minus 2a. Okay, so this will be 1 by 2 into minus 2a into 1 minus a squared power minus 1 by 2. So this can be written as 2 and 2 will get cancelled. So it is minus a into 1 minus a square the whole power minus 1 by 2. So I can bring that negative power to denominator. So I can write it as x plus of minus a divided by square root of 1 minus a square into y plus c is equal to 0. And next one, if I differentiate with respect to c, I'll be getting 1 equal to 0. So there will be no singular integral in this question. Okay. To find the general integral, I'm going to replace the second arbitrary constant c with delta of a. So the complete integral will be z equal to ax plus square root of 1 minus a squared into y plus delta of a. Next, I'm going to differentiate this one with respect to a. So I'll be getting x and derivative of this root 1 minus a square. We have already done that in previous question. So it is minus a divided by square root of 1 minus a squared into y plus delta dash of a, this will be equal to 0. Now eliminating a from these two equations, we'll obtain the general integral. Question number 3, p plus q is equal to pq. To find the complete integral, we are assuming z equal to ax plus by plus c as trial solution. So now substituting p as a and q as b, will be getting a plus b is equal to ab. Now what we are doing is, we are bringing this term to here and this term to here. So b minus ab will be equal to minus a. So b into 1 minus a is equal to minus a. So b can be written as minus a divided by 1 minus a, or bringing that negative sign to denominator, we can write it as a by a minus 1. So now our solution will be z is equal to ax plus a by a minus 1 into y plus c. So this is our complete solution, because there are two arbitrary constants a and c and two independent variables x and y. So this will be our complete integral. Next one, to find the singular integral, we are writing first equation, complete integral, that is ax plus a by a minus 1 into y plus c is equal to plus c. So this equal to 0 will not be there. And second one, we are going to differentiate this complete integral with respect to a. So it will be x, and differentiating this one, we are going to differentiate this in uv format. So it will be a minus 1 the whole square, b square in denominator, v u dash is 1 minus u v dash is also 1. So you will be getting a minus 1 minus a divided by a minus 1 the whole square. So plus a and minus a will get cancelled. We will be getting minus 1 divided by a minus 1 the whole square. So the derivative is minus 1 by a minus 1 the whole square into y plus c. Plus c will not be there. Plus 0 is equal to 0. And next one, differentiating the complete integral with respect to c, will be getting 1 is equal to 0. So there is no singular integral for this type. To find general integral, we are going to put c is equal to delta of a. So z equal to ax minus a divided by a minus 1 into y plus delta of a. So here differentiating this one with respect to a, will be getting x minus 1 by a minus 1 the whole square y plus delta dash of a, this is equal to 0. Now eliminating a from these two equations, we will obtain the general integral. Thank you.